Hello. How are you? We've got an exciting, I guess it's exciting, section 3-4 video on slope of lines. So a lot of this is going to be review from things that you learned last year in algebra. So some of it I'm going to go a little quick through, and other things I'll slow down and explain. So tell me, what's slope? When you think about slope, what is it that you think about? I'm going to guess that probably a lot of you thought about rise over run. That's the little catchphrase we always use. But what does that really mean? Rise over run, remember, is your rise is a change in the vertical or the change in the y values, while your run is a change in the x values, all right, or a change in the horizontal. Okay, so we can take that and we can create what is referred to as the slope formula. And you'll hear me use this phrase throughout the video. That's y minus y over x minus x. Now I know a lot of you from last year in algebra learned to put the little subscripts in. You are more than welcome to put the subscripts in, but if that confuses you at all, you are perfectly welcome to erase those, to get those out of there. And just to remember my important phrase that anytime you are doing work on a graph, be consistent. That is correct. Be consistent. I know that I heard you yell that out just now as you watched the video. Alright, so let's do a little practice here. If we know that A is at 3, 2 and B is at -1, 6, what is the slope of the line that goes through AB, or what is the slope of segment AB? Alright, so to do that, we want to take our y's, and you can subtract in whatever order you want. I'm going to go 2 minus 6, and then to be consistent, I need to do 3 minus -1. So on top, that's -4. On the bottom, I'm going to add the opposite here, so that's really 3 plus 1, which is a positive 4. I'm going to reduce that to -1 over 1, and I want to leave that as a fraction. I always want to remind myself that slope is always two things. It is a rise and it's a run. Alright, so at this time I want you to practice these two problems. Make sure that you know how to do this on your own. So for the first one, we're going to look at segment CD. So C is -2, 2 and D is 0, 8. I want you to find the slope of segment CD. We're also going to look at segment EF. So E is 4, 7 and F is 6, 7. What is the slope of segment EF? Please stop the video right now and work on those. Alright, so hopefully you did something like this. 8 minus 2 over 0 minus a -2, so that's 6 over a positive 2, which is going to reduce to 3 over 1. Even though it's a whole number, I'm going to leave it as 3 over 1. For the other one, it's 7 minus 7 over 6 minus 4, so 0 over 2 is 0. I would consider a slope of 0 a special case. We'll talk about special cases here in just a moment. So hopefully you got the same things. If not, go back and look at what I did again. So, special cases. I put this on graph paper because I think special cases are best to understand when you graph them. So in my opinion, there are two special cases when you're graphing lines. Most lines are diagonal, but you've got horizontal lines and you've got vertical lines, and the slopes of these lines sometimes are confusing to people. So if I was to graph a horizontal line, it can be any horizontal line, any line that crosses the y-axis. What is the slope of that line? So in my opinion, the best way to do this is just to pick 2 points that are on that line. So I'm going to choose 1, 2. Actually, that's 1, 2. So that's a mistake. So everything I have right now is wrong on here. And then that is 4, 2. So even though the slope ends up being 0, there is really bad math on this. Alright, go back and make sure you have the correct answers for there. But your slope is 0. That's the bottom line. Now, for vertical lines, I've got what slope for this line? So again, I'm going to use the same technique. That point right there is -2, 2. And then I'm going to choose this point down here at -2, -1. Alright, so now I put them in my slope formula. 2 minus the -1 over -2 minus the -2. And make sure you're careful on all of your negative signs there. This is going to end up being 3 over 0. We can't divide by 0. If you try to divide by 0 on your calculator, it's going to give you an error. And what we're going to say then is this means that it is undefined or no slope. So to answer the question, what is the slope of a vertical line? The slope is no slope. It has no slope. Alright, so make sure you've got those ideas. Use the correct points back on that horizontal line, not what I've written down. If you remember, ask me next time you see me about a really, really horribly awful way to remember the slope of a horizontal line and a vertical line. It is so awful that it's actually really good, and I remember it every time I teach this. Alright, so let's connect this now to some of the geometry that we've been working on lately. So there's two postulates we're going to look at. Neither of these postulates are postulates that you would use on a proof, alright, but they are postulates that we're going to use to solve some of these graphing problems. So the first postulate, postulate 17, says parallel lines have equal slopes. And in my opinion, the best way to think about this is to think about like if you were skiing. I don't know if you've ever been up to Boyne Highlands, but Boyne Highlands is right across the street from Nubbs Knob. Alright, so theoretically you could be standing on the top of a hill at Boyne Highlands ready to ski, and you could see your buddy standing on the top of a hill over at Nubbs Knob. And let's just pretend for sake of argument that you're skiing down two hills that look roughly the same, like they be the same like difficulty factor. I would argue that since they're the same kind of hill, that we might call them parallel to each other. And you can see on my graph or on my picture right now that those two slopes would be exactly the same. The slope of those two mountains, alright, would be the same. So the idea here is parallel lines have equal slopes. The second postulate we're going to look at today is postulate 18. This one says that perpendicular lines have slopes whose product, remember product means multiplication problem, so perpendicular lines have slopes whose product equals -1. That means if you were to take the two slopes and multiply them together, the answer would be -1. So look at some examples of this. All right, but I guess what I would rather say is I don't really think of it this way. I think of it as these are slopes that are opposite reciprocals. There's two things there. One means that one is positive and one is negative, and then it also means that one is flipped upside down from the other. Some teachers call those flippicals. So I could have a slope of 2/3. Its opposite reciprocal is -3/2. I could have a slope of 5/7. Its opposite reciprocal is -7/5. And -1/3 has an opposite reciprocal of 3/1. Now, you can think of it like that, or you can multiply these out. That's -6/6, which is -1. This is -35/35, which is -1. And then this is 3/3, which is -1. And so the product is always the same, but I just like to think of them as opposite reciprocals. Alright? So let's just practice this for one time and see if you understand what I'm talking about. And by the way, if I'm going fast, stop, go back, watch it again, listen to it. So if I tell you that the line of line AB has a slope of 3/2, you should be able to tell me what the slope of CD would be if it's parallel to AB. Likewise, you should be able to tell me what the slope of EF would be if EF is perpendicular to AB. So, stop the video here right when you get a chance and answer those questions quickly. Alright, hopefully you got the slope of CD to be 3/2 since it's the same, and you have the slope of EF to be negative 2/3 since it's the opposite reciprocal. Got the idea? So, last thing, let's do some examples of this. If these are typical homework questions, they could be potential quiz or test questions. These are the kind of things I'm going to be most likely to ask you from this section. Alright, so question number 1. Suppose that I tell you that a line goes through the points 3, 0, and 7, 6. What would the slope of a line that is perpendicular to this line be? What would the slope of a line perpendicular to this line be? So, I'll give you some steps here. Step number 1, we're going to use the slope formula, and we're going to find the slope of our original line. We're going to find the slope of the line that contains 3, 0, and 7, 6. Okay? So, I'm going to go 6 minus 0. You could do the other way around if you wanted to. And then 7 minus 3. Alright, so 6 minus 0 is 6. 7 minus 3 is 4. I'm going to reduce that to 3 over 2. Divide both the top and the bottom by 2. Now, second thing, what does perpendicular mean in reference to slopes? What did I just talk about, about perpendicular lines? So remember, perpendicular means that they are opposite reciprocals. So if the original line had a slope of 3/2, then my new line is going to have a slope of negative 2 over 3. Opposite, so one's positive, one's negative, and then flip it upside down, and now it's negative 2/3. The other question that you need to be able to do is if I tell you that segment AB has points 0, 3 and 5, 2. Now I want you to find the value of x. If there's a second segment, we'll call it CD, that contains the points 1, 2 and x, 7, so we don't exactly know where that point is at, and this CD is parallel to AB. If you think you have an idea how to do that, push pause right now before I walk you through it. Alright, so you either push pause and you figured it out, or you don't really have a clue, and so I'm going to walk you through it right now. Step 1, let's find the slope of the line we can actually find the slope of, which is AB. So using slope formula, 3 minus 2 over 0 minus 5 gives us negative 1/5. Now, important word in the problem is parallel. So what does parallel mean with regards to slope? Parallel means that the slopes are equal. So if the slope of AB is negative 1/5, then the slope of CD is going to be what? That's right, negative 1/5. So last step now. Now we're going to use the slope formula one more time, and we're going to plug in the points for CD, but since we don't know what x is, we're going to have an answer now for this, and we know the answer is negative 1/5. So 7 minus 2 over x minus 1 has to equal that slope we just found, that negative 1/5. How do you solve this? I'm going to simplify, and I'm going to cross multiply. 5 times negative 5 is negative 25. And then I got to make sure I distribute that 1 through the other side, so 1 times x is x, and 1 times negative 1 is negative 1. Add 1, and I get x equals negative 24. That is the x value of the point that would make CD parallel to AB. Definitely want to practice these problems as you do your homework assignment for the rest of the time you have, and that homework assignment is on page 175. Let's do problems 3 through 32 and 36. Thank you. Have a good one.